In this lesson, we are going to be looking at two examples of drawing our straight line graph. Now, you need to identify that. Y is equal to 5x minus 3. You must be able to identify that as a linear function, that we would be able to draw that as a straight line graph. If you don't, I suggest that you watch the videos before this one. That's part of this section. All right, so that is definitely in standard form, where that is our gradient, and that is our c value, which is our y-intercept. So we need to go plot those points. But now we need to be careful. So we can go ahead and we can plot our y-intercept. Our y-intercept, you need to know this, is 0 and -3, because we just read it off the graph. It is our c value. So we can immediately go plot that. But there's different ways to draw your straight line function. It doesn't matter how you go about it. If you use a table method, or I know there is a method, what's that other method? The gradient intercept method. I just use the dual intercept method, where I find my y-intercept. It's right there. And then I find my x-intercept. How do we find the x-intercept? We just go and make our y 0. Why does that work? Because if you think about it, if you are right there on your x-axis, anywhere on your x-axis, doesn't matter where, what is y? Your y is 0. Your y stays 0 the whole time. So if you, for your output value, put in that your y is 0, it will give you the x input value. So that will give you the x-intercept every single time. Okay, so let's go ahead and do that. Our output value y is 0, and then we've got that 5x, take away 3, and now we just have a simple equation that we need to solve. So I am going to add 3 on this side so that those cancel out, but what I do on the one side, I must do on the other side. And now I want x by itself. 5 is being multiplied by the x, so to get rid of it, I need to divide so that I have x by itself, but then I need to do that on both sides. So my x is equal to 3 over 5. So what did we just find? Grade 9s, where my x is 3 over 5, my y is 0. I plugged in my y as 0. Okay, perfect. So we've got 2 points that we need to go plot. But now let's just quickly think about the scale. If we go plot 3 over 5, it is literally somewhere over there. Yeah, I mean, I guess we can do that. We can also use 2 blocks for 1 unit. We could also use, no, we're going to run out of space if we use 5 blocks for 1 unit. That would have been nice though, since we are dealing with fifths. But I think for our scale, let's go put 2 blocks as 1 unit. 2 blocks is 1, like that. Okay, you don't have to do that. I don't have to do that, but I am doing it. Okay, let's plot our y-intercept, 0 and -3. So 1, 2, so -3 would be there. And then our x-intercept is by 3 over 5. Where is 3 over 5? Well, I mean, if 1 is there, 3 over 5, I would say, is roughly over there. Make sure that you can plot your fractions. And these are 2 points that we can now draw our line. So there is our line. Oh, that's pretty good. Yay. Okay. There's our line. And then what you need to do is you just need to go put in the points. That's the points of intersection. So that would be 0 and -3. And that one would be 3 over 5 and 0. And there is our straight line. Let's just double check if it makes sense. Well, our gradient is positive. So yes, it is a positive direction. 5 is a pretty steep gradient. So yes, that makes sense. And is our y-intercept there? Yes, it is. So that looks pretty good. Okay, one more. Make sure that you practice this enough, because this is something that you're always going to be asked. Okay, it says that we need to draw this graph. Let's just make sense of that. If this looks funny to you and you can't see what the gradient is, refer back to the video on on standard form. Refer back to the video on standard form, just that you can make sense of that, the end of that video. Okay, so we need to plot that. You need to know that this one you can go right as negative 1 over 3 times x. It's exactly the same. It just looks a little bit different. And then plus 5. That is our c value, our y-intercept. That is our gradient, our m value, the steepness of the line. Okay, let's kind of make a rough sketch of what we think this looks like before we go plot it accurately. Well, the fact that it's by plus 5 is our y-intercept, so it's going to cut somewhere over there. And since our gradient is smallish and also negative, I think our line is going to be something like that. All right, let's go work it out. We know that our y-intercept will be by 0 and 5. Our c value, we just read it off there. Let's go find the x-intercept. Again, however you want to go draw this grade 9, it doesn't matter, just as long as we get the same graph there. I just find dual intercept the easiest, where you have your y-intercept, x-intercept, and we plot that. So x-intercept is where we make our y 0. So our output, y is 0, and then we have to solve for x. So x over 3 plus 5. And not just one way of solving that simple equation, obviously. So just as long as you get the same answer as me, I want to isolate that x. So the first thing that I'm going to go do is I'm going to go get rid of that 5 by subtracting 5 on the left so that they cancel out. But then I also have to subtract 5 on the right, and I also need to subtract 5 on the left. I'm sorry about that, my tongue twisters. Okay, then on the right, we are left with that. I want my x by itself. What is in the way? Well, I'm just going to go multiply this side by 3, because since we are currently dividing by 3, the inverse operation, the thing that will make it go away, is if we multiply by 3, but then as long as I do it on both sides. So then on the left, I've got negative 15, and I'm left with a negative x. And then, remember, there's a coefficient. I'm just going to divide both sides by negative 1, and then I've got that x is equal to 15. So there is the x-intercept that we can go plot, where my y is 0, my x is 15. All right, let's go plot those 2 points. I'm going to plot my y-intercept first. 1, 2, 3, 4, 5. Oh, we won't be able to plot 15. I don't have enough lines there. But we can make a plan. Let's solve this problem. Let's use every single line as 2. So that would be 2, 4, 6. That would be 2, 4, 6. Okay, problem solved. So where is my y-intercept? 5. So that would be 2, 4, 5. So that would be in the middle over there. And then my x would be by 15. So let me just quickly 2, 4, 6, 8, 10, 12, 14, 16 is there. Where is it now? Is it there? 2, 4, 6, 8, 10, 12, 14. Yeah. And there are our 2 intercepts. And now we can go draw a line. Let's see if I can do this one first time. Luck again. So it goes through. No. Whoops. Okay, there it is. Just give me a moment that I can just get that one through there. Close enough. Okay, perfect. There is, oopsie, no, that's not good. Okay, that's better. And now remember to just go indicate your points of intersection. That one would be 0 and 5. And that one would be 15 and 0. And I think my estimation over there, yeah, wasn't too bad. What do you think?